All right, so what we're going to learn today is about how to complete the homework assignment, or the mini project one, and we're going to learn about Markdown and what it is and how to use it and how to make links, how to add pictures, how to add a change log or a task list, and just generally understand what Markdown is and why do people use it. Okay, so the first thing I'm going to do is I'm going to do the quickie, get a GitHub repository and make a project on my computer. So I'm going to go to GitHub, and you could maybe do this to start mini project one. So I'm going to do new repository, and I'm just going to call this mini project 1601 JC. All right, now when we come down here, I'm going to initialize it with a README. I'm not going to put a get ignore in right now, and I'm just going to put an MIT license in. And I sometimes get questions about what an MIT license is, and basically the MIT license is just giving away whatever's inside this repository. It's a license that removes all of your rights and all responsibilities. So you have no responsibility to whatever somebody does with it, and you have no rights to the copying of it. And the MIT license is the most common license today for code. So like all the libraries and stuff that people use, they usually license them as MIT because people as a developer, you have to see what the license is of the library because you don't want to accidentally use something and get sued. And some companies will have policies about what kind of licenses they'll use, and usually MIT licenses, since they can be used in commercial projects and sold, and there's no requirement to give back or do anything, MIT license is the cleanest license to use for anything, unless you have some particular thing you want to do. So I'm going to create this repository, and blow this up a little bit. So we got a license, and we got a README file, and then this README file, as you've noticed probably, is displayed automatically inside the mini. It is automatically displayed on the home page of the Git project, right? So what we're going to do is I'm going to take and clone this repository. However, what I'm going to do is we're going to learn a new thing today. Okay, a little new. We're going to do like little tiny new things. Did you notice how whenever you had to push the GitHub, it keeps asking you for the username and password? All right. Well, now that you're going to be working in a team, and sometimes you might work at night with somebody, and you might have to be pushing and pulling a lot, and it's like it slows you down to have to keep entering your username and password. Well, what we're going to do is I'm going to show you a way, and we'll talk about a little bit what it means, how not to have to enter in your username and password every time you do push requests or pushes. Okay. All right. So I'll go through this slowly. So what we're going to do is here by default you usually have HTTPS. I'm going to switch to SSH. Okay. Now, let me explain what SSH is real quick. So, SSH stands for Secure Socket Shell, or Secure Shell. What SSH is when you log into a remote computer and you have a terminal, the server and the network protocol that is serving and sending commands back and forth between your local and the remote server, and it's securing the transfer of the information and taking the commands from the server and then sending them to the operating system. It's like a bridge between the outside world and the internal computer. That's called an SSH daemon. And a daemon is another word for server. Okay, so because sometimes if you hear a daemon is a server, but really we should always call them daemons, because server gets mixed up with a computer or it gets mixed up with some other thing. But a daemon is actually a memory resident program that is sitting in the background of your computer and running all the time, and then it can be used as a server, because the server has to be on all the time. So there's a thing called SSHD in your Ubuntu or any other Linux distribution, and that's the secure socket shell daemon. And then that is the server that you connect to and your commands get transferred back and forth to. Does that make a little sense? Okay, so what we're going to do is we're going to take SSH and use that instead of HTTPS. The HTTPS is Hypertext Transfer Protocol secure, and that's basically transferring things over the internet. Now, as a little note, and we're going to get deep into the way the internet works probably in a couple weeks, but SSH works on port 22, and the HTTPS works on port 443, and regular HTTP works on port 80. Just as a little aside, every daemon, every server piece of software has to bind, which connect to, what's called a port. And every computer has like 65,000 ports approximately. And those little ports are like, imagine you had telephone wires that the communication would go over. So each daemon, each server binds to one telephone wire, and then that's its dedicated telephone wire, that's its dedicated port, and then that's where the communications go over. And that off the top of your head, you should always know, like, hey, port 80 is internet, port 443 is secure internet, port 22 is SSH. Okay, like that's common knowledge that everybody in tech should know, because like you just, it's something that comes up whenever you use FTPs and SFTPs and all sorts of stuff. So FTP, you ever hear of FTP? A little trivia. So there's FTP, which stands for File Transfer Protocol. That runs on port 21, and that's unsecure. There's no encryption with that. You can have a password, but there's no encryption. If you ever heard of SFTP, Secure File Transfer Protocol, SFTP is SSH. So Secure Socket Shell and SFTP are the actual same daemon, and it's just that SFTP, which is used to transfer files, is how SSH transfers files from one computer to another. And then they call SSH Secure Socket Shell, but it has two parts. It has one channel for commands and one channel for files, but it always runs on port 22, unless it's somebody purposefully changes it from port 22 to hide the fact that it's on that port, because sometimes for security purposes, you don't want your SSH server to be, since you have 65,000 potential choices and the standard is port 22, sometimes security people will change the port of SSH to a different port in order to do something. One of the things that you should write down and keep in your memory, because this will happen to you if it hasn't already, when you get a message on it for an error and you read it, and it could be on all different types of programs, but if you see a message that says something like when you're trying to start up Docker container or a server, if it says unable to bind to port already in use, what that means, and that's like the standard error message, but it could be in different things, unable to bind to port to use, that means that some other program has already taken the port, taken the network connector, imagine that telephone wire, and is using it, and you can't have two computer programs use the same port at the same time. Does that make sense? So if you ever wondered why can you have like a web server, a database server, browse the internet, do a bunch of different things on your computer that use a network connection, the reason why your computer can use a bunch of different things using the same internet connection is because that internet connection is broken down into 65,000 ports, and each one of those ports can do a separate thing. Does that make a little sense? Okay, so ports are basic networking that you should understand. If you don't understand what I'm saying about ports, I would go and port myself. So I would go and read about ports. But that's the thing is sometimes somebody will say, oh, why don't you just FTP in there? But they won't tell you the port. And if they don't tell you the port and something asks you what port to use when you're filling out the form to connect, you'd be like, oh, FTP, it's 21. SFTP, it's 22. I'm trying to set up a web server, it's going to be 80. I need HTTPS for a secure web server, it's 443. That's basically the ones you have to remember. Like mail is like port 25, but mostly you don't ever have to deal with port 25 on mail, and mails have a couple different ports. So what I'm going to do is I'm going to get this SSH link, and this is basically, rather than sending the project or the commits and everything over the internet, over port 80 or port 443, because we were using the HTTPS link, now when we send our commits and everything, we're going to be sending over port 22 because that's going to be SSH. So essentially now our computer is, rather than using sort of an internet protocol to access our repository, we're going to be using the secure socket shell protocol to access our repository. So I'm going to copy this, and then I'm going to go open up my terminal. And let me give myself a little space here because this is a little hard to see. But what we're going to do here is just like we did before. So I'm going to do a PWD just to see where I'm at. So like I'm inside of a mini project already. So we're going to do a new one. So I'm going to back out. CD ... is how you go reverse. It's like putting the car in reverse. CD ... is put the car in reverse. And you can always reverse with ... So if you're trying to specify file paths to access something, so you could be in one directory, and if you want to get out of that directory and grab something from above, you would put ... and then it backs the car up and goes to the next directory. And if you had to back up 2 directories, you do CD ... /... So ... always puts the basically where the file system or where your command prompt is looking for the data. It always reverses it one directory. So what I'm going to do here is I'm just going to do a git clone and paste this in. And you can see how it's different, right? Isn't this different than HTTPS? It's like git at GitHub. So this is the user. Then this is the account. And then that's the repository. It's different than the HTTPS if you look at it. It looks like an email address with an extra piece on it. So I'm going to clone this. And what I'm going to do is I'm going to cause my pushing to fail. So what I'm going to do is I'll do this real quick because we're going to redo this. I just want to get rid of my old key. So I'm going to go back to my command line, and what I'm going to do is I'm going to do an edit. I'm going to show you one thing in Markdown just to save time, and then I'm going to try to push, and then it's not going to let me push, and I'm going to show you how to fix the push. Okay, just because we got to do a little edit. So I'm going to do vi readme. Oops, sorry. cd MiniProject AC vi readme, and then the first thing we're going to do is I'm going to go over to my Markdown tutorial here. I got it somewhere. And if you want this, I'll put it into Slack real quick so if you can pull it up so you can copy and paste everything with me. All right, so the gist of Markdown is people made I forget who made it, but they made Markdown so you don't have to write HTML as much. So what Markdown is what's called a DSL. A DSL stands for Domain Specific Language. It's like a computer programming language that was designed for a specific purpose, so it doesn't have maybe it doesn't have variables, it doesn't have if statements, it doesn't have certain things in it, but it gets read by an interpreter and then processed and an output comes out. So there are different domain DSLs, domain-specific languages, for different purposes. Got it? So Markdown is a DSL for HTML. And it's really good to know Markdown because here's where you see it. You see it in the README files, you see it in wikis, you see it all over the place on the internet because a lot of times, for example, whenever I'm making a computer program, if I have to have user text come into my computer program, I don't allow HTML tags. Like I just don't allow HTML. I'll allow Markdown because Markdown has to be processed and no junk can get into my system. Like there can't be any security problem with the HTML. People can put weird HTML in that can cause problems. So Markdown has a limited set of tags. It's got a limited set of things, and it's like a screener for it. If you use it, it's just not going to let you put bad tags in. And just to give you an example, so let's zoom up here. So here's some text, and then to get bold, I do the 2 stars by it, and then that's what makes this bold. Or italics, I put a star on it in the front and back, and then that gives me the italic. All right, and then this link to Google, see it says link to Google? That's how I make a web link. Okay, so what I'm going to do is I'm just going to take this code, and I'm going to go over to my terminal, and I'm going to paste this in. And just to compare, like if we wanted to do a web link, and we'll do a little like HTML crash course of like what you should know about HTML before the course is over. But see, I'd have to write all this out. Like see how I'd have to write href, that's where the URL goes, that's where the text goes, and I have to remember to close the tag. So is it easier to write this or just put the link text in a brackets and put parentheses around the URL? This is easier. And not only is it easier, is it less, are you more likely to make a mistake having to close tags? Like to forget to do that? Okay, well, when you have HTML that doesn't have its tag closed, it gets all screwed up. Okay, it's sort of like the HTML processor just like says, "Oh my God, the tag is not closed," and it'll think that the next tag is what's closing it, and you'll end up with a link that's the whole entire paragraph or something, and it'll be all messed up. So the Markdown was invented basically just to make it easier for you to write HTML without making mistakes, and to make it so you can't put junk into text input boxes. So some things like, for instance, in GitHub, they don't allow HTML in comments, but they allow Markdown inside their comments because they don't want to worry about HTML vulnerabilities of things that could get put into their system to make it a little bit more secure. Now, Markdown's really good to learn and know it with Git because remember, I think we talked about earlier where we talked about the Mythical Man Month, and in order to solve the problem of getting computer programs made faster, you had like one main developer who was the surgeon, and then you had like a junior that worked with them, but then you had jobs divided up to a bunch of other people. Well, one of those jobs usually today is documenter. Like somebody who's like knows a little bit of code, but they do most of the documentation. Because if you got your Usain Bolt of programming, do you really want him or her writing a whole bunch of documentation and like detailed comments and everything about their work, or would you rather just have them code like a demon, and then have somebody else read the code and then write the comments in and do the documentation? So people get hired literally just to read code and put documentation in with Markdown. Does this make a little sense? So like if you say I know GitHub and Git, that means, okay, you can push and pull and you can work in a team. And then you say Markdown, well, I know that I got a job for you because I got my Usain Bolt and he doesn't want to write comments. He sucks at that. But we need comments and we need some information documented so that when Usain Bolt goes and gets drafted by, the Patriots or goes somewhere else other than us, we have records of what he did. But that guy or girl usually doesn't want to do that because it slows them down. And I personally don't want to pay him $100 an hour or whatever to go and make sure everything is easily readable in English. Do you make sense? It's easier to pay a junior that knows Markdown and Git, and they'll learn from them. Like that's like a junior developer a lot of times might read from what the developer might do and put the documentation in. Also, as we do REST APIs, just to show you this is like I'm going to show you the Twitter REST API. So most of the systems today are all about what's called a REST API. And a REST API is basically, imagine that you have a database on one side, on your left hand, and then you have the internet on your right hand, and the body in the middle is the application. And that application, what it's doing is checking credentials and preparing data to come out of the database and formatting it to be sent to a client of whatever is being requesting the data. All right. Well, those REST APIs are how all companies pretty much are building their, either already have or are building their data infrastructure. And those REST APIs need to be documented so that people can read them. So you need a little bit of programming skill to understand what the API is and maybe to test it and stuff. But then people are writing like for instance, Twitter, they have to write these guides and API references and such. And these are sort of technology analyst type positions that know how to write Markdown because all this stuff is written in Markdown. Like it's written in Markdown, and then there's a Markdown processor that just takes the Markdown and turns it into HTML. And like you just need to know Markdown. Like it's really useful. Like I had a girl who, when my undergraduate, and this is kind of maybe an exception story, but she got a job at Goldman Sachs because she knew Git and Markdown, and exactly what I was saying, that they had people, they were doing, they were upgrading their infrastructure, and they hired her as an intern, and she eventually got a job at Goldman Sachs because she was the one doing Markdown documentation and keeping track of whatever had to be sent to her, and then able to push up to GitHub or to Git. She didn't code, she didn't do much. She's probably doing something now, but that's how she got her foot in the door for Goldman Sachs. Because you kind of can't just grab somebody off the street and be like, oh, go do my Markdown and do my Git. Like learning Git is like a 3 to 6 month process, I think, for people to get good at it. And learning the other stuff is like a few months. So companies won't train you to do these things. But once you go in and know them, then they're like, oh, I don't have to train you on all this basic stuff. And then you have a shot at getting the job because they're desperate to hire people. All right, now, so I'm going to go back to here. So we all got the idea what Markdown is. It's just a domain-specific language that writes HTML, and it makes it easier to write HTML. And there's a document that shows you all of the Markdown functionality that is I sent you in Slack, and it's posted into the system. So what I'm going to do is I'm just going to right quit this out, and then I'm going to do a git add readme, a git commit -m, and then maybe I said feature added Markdown example. All right, and then what I'm going to do is I'm going to do a git push origin master, and it's going to go and it's going to say, and this is a common error that doesn't just happen here, it happens other places, and this is like filled with vocabulary words that we need to know. All right, the error says permission denied, parentheses, public key, could not read from remote repository. Please make sure you have the correct access rights for the repository. Now the key, like the key sentence that I look for, and this is where you see this in other places, it'll say permission denied public key. All right, and what we're gonna do right now, this is like important to know how to do this, because it's, just explain this. public key encryption is how all the internet works for security. So what public key encryption is that you end up generating what's called a private key, and that private key makes a public key. The private key is like the key factory. The private key can generate new public keys. Follow? So it's like imagine it's a key factory. And the private key can check whether or not the public key is right. Okay, so the private key is the factory of keys, and it's also the lock that checks whether or not the public keys that have been generated come from the factory of private keys. Does this make a little sense? So the way you can, another part of this is the way you can think of a private and public key. One second. The way you can think of a private and public key is that it's just a giant password. That's what it is. It's just a password, and we're going to take a look at making one and see what it looks like. And it's just a 2,000 plus character password. It's just, and then go ahead and ask your question.
Yeah, so for the private key, so you said private key is used to generate the public key.
Yeah.
Now, I guess the consumer only gets the public key, right?
Yeah.
And who holds the private key stays with the service provider?
No, the private key in this case, it can be different things. So like, in this case, my private key will stay with my computer. Okay? Then when I'm going to go to GitHub, and I'm going to take the public key and I'm going to put it in GitHub. All right? And then whenever I try to log into my account in GitHub, it's going to say, oh, do you have the private key? Like, it's going to generate a message. And it's going to say, when I'm trying to log in, it's like going to send a generated token that's like, here's this generated token from the private key, and then the public key on the other side has to decode it. And then it'll say if you decode it, it's good. The private key stays on the machine usually that's generated it. But it could be moved. You see, the thing is that this is, okay, so let's understand this. Let's like understand okay, forget about what machine the key's on. You have to think of what does the key do. Okay, private keys can generate public keys that are matched to themselves, like it's matched, and the private key can generate a token that will go with a message that says that this is coming from the private key that is here. So like it doesn't send itself, it doesn't send a public key and it doesn't send a private key, but when I try to log in, it's going to send some like mixed up text and over to the side.
So it's like a common token that both can understand or derive.
That's like the private keys both public and private keys can generate tokens, but only private keys can generate public keys. Okay. So they can both talk back and forth, but the master is the private key. That's like the gold master of that connection. Does that answer your question? Because I can take this private key and I could put it on your computer, and then if it was on your computer, you'd be able to go to my GitHub. Right. Because your private key is the same one on mine, you can generate it, okay? However, if, let's say, you usually want these private keys to be hyper-secured, like these are kept in the most secure place of your business, because, so for example, and this is real, like Apple, when they put the operating system on your iPhone, Apple has a private key that is used to encrypt the data that is the operating system and everything that's on your phone, okay? Apple private key could be probably stored in one place, might not, but it's probably stored in one place. I'm sure there's a backup or something. But that one private key is what makes sure that all the Apple phones in the world are not able to be broken into. Like that they're not able to be just like SSH'd into and file systems read and opened. Does that make a little sense? So, but if let's say the private key was compromised, so somebody stole the private key, then what I'd have to do is invalidate the private key. I'd have to destroy the private key that was was compromised, generate a new private key. But my problem is all those Apple devices out in the wild, they're all on the old public key. And before I fix this, I'd have to figure out a way to distribute new public keys to all of you. Because as soon as that private key is done, destroyed, not there, then all the public keys that were created by it are also invalidated. Does that make a little sense? Go ahead.
So when you just issue a software update?
Well, I don't know exactly how Apple works, but in order to do the software update, that's what they're using the keys for.
Gotcha.
So it could be a real, and that's why, so in the history, there was a fight between the U.S., I don't know exactly the resolution of it, but they found a cell phone that was a terrorist, and it was an Apple phone. I don't think, and Apple wouldn't open it. And Apple wouldn't give the government the tools to open it because in order to open the phone up to get the data out, Apple would have had to give the government their private key that controls all of the iPhones in the world, and they just weren't going to do it. I think they ended up saying like, we'll do it for you maybe, but we're not going to give you the private key because if the U.S. government got the private key, then the U.S. government, whoever had that private key, could open up anybody's iPhone, and that could open the door to the problem that Apple would have of how do I get updates to computers that I've had to invalidate the private key. Like you might have, it gets all screwy with it. So
But does
these,
the government already have access to the,
no,
they should
well,
have
this
CC
is
have
so.
to
Let's talk about
regulate
that another day because I keep that up because I have my own opinion about that and I don't want to put that in the lecture. All right, so but these are good questions to have in the lecture. All right, so how do I fix this? All right, so how do I generate a key? What do I do with it? So it's real easy, and if you have Git installed on Windows, I believe that gives you the command. So this works everywhere. It's command ssh keygen, and what we're going to want to do is it's going to say generating public-private RSA key pair, enter a file to which to save. Do not enter anything. Don't put a period. Don't put nothing. Just hit enter because this key has to be where it tells it to put. Like there are reasons why you might want to put the key somewhere else, but in our instances, if you put that key somewhere else, it ain't gonna work.
I pressed enter and it said enter passphrase.
And then the passphrase, I'm gonna overwrite my key because I'm gonna get a new one and I'm putting it in. But the passphrase, don't put a passphrase. So I just hit enter and enter. Okay, I'll explain what the passphrase is. So remember how I said the private key is. Do you realize what the private key does? It's the key factory, and if you have that the way things are secured is using these public-private keys from Apple's phones and Android, and with the way servers are connected, and basically the whole internet is secured with private-public keys. So our keys, like on our computer to GitHub, these keys are not worth a lot of money, okay? And we have to push to GitHub all the time, and so we don't want a password on it because if you put a password on it, it sort of double encrypts. It encrypts the private key so that you have to have a password every time you want to open the private key file or use the private key file. But we don't. Our whole point to doing this is so that we don't have to type a password in every time we log into GitHub. Does that make sense? So we don't want to type a username and password every time in GitHub. Why we shouldn't put a passphrase on our key because we don't want to type password in. And the only way that someone can get into our GitHub with this key is for them to come into your computer, go find the private key, and know that this private key matches what's inside of GitHub. So the security threat for you guys to do this might be low. Now, some companies, depending on where you're working, like if you work at Chase Bank and you do banking stuff, or they might make you put a passphrase on it just because it's like they're doing hypersecurity. All right, but for our stuff, we don't have to do a passphrase because nobody's going to steal our stuff. Okay.
For us, we don't even get to touch those keys. Somebody else, there's a whole department that they put in a vault
Right, there's like going to be, they're going to print it out and put it in a vault, and like that's the backup, and then it has like, these keys are super sensitive, like as far as the information, because this is the way the internet is secured. This is the way the banks are secured. This is the way everything is locked down. So, and you notice that do you ever see HTTPS and HTTP? So basically what happens is that that's public-private key authentication. So there's the browser manufacturer gets a key, I believe a public key, and then that browser manufacturer inside the web servers, like Apache, Internet Explorer, those have keys for the private keys for the browsers. And you can change that. Like you have to get an SSL certificate. You ever hear of SSL certificates? So like, let me just show you real quick. Like GoDaddy, SSL. And so just a real quick interesting thing is when I want to put SSL on or HTTPS on a computer, what I do is I buy a SSL certificate, okay? And that's basically a way to generate a private public key. And that I put a key inside my server, and that key was identified as coming from an authorized SSL provider. And then because the authorized providers are programmed into the web browsers, that's why my key from GoDaddy will work in all the web browsers. So imagine like GoDaddy has a mothership of making keys, and GoDaddy went through all the security stuff to say, hey, we're going to make our keys work in all the web browsers. So then they sell you a process, essentially, to generate a private public key pair that goes into your web server, an SSL certificate. And then that SSL certificate will say, hey, this security certificate was issued to so-and-so, and this certificate came from GoDaddy. And because we know GoDaddy and trust GoDaddy and GoDaddy trusts you, we're going to give you access over HTTPS, which is the encryption of public-private key, basically. Does that make a little sense? So understanding like public-private keys, and just like if you don't understand what I'm talking about, maybe we'll put this as part of a homework too or something. But it's real important. Like it's the security of the internet, and you might be like, so for example, somebody's going to ask you, hey, go on your laptop, generate me a public key, and go on the laptop, do SSH keygen, take the public key file, which is I open it up with Vi, and one of the reasons why I like Vi and not using Notepad or something is because Vi doesn't make mistakes. Like it's hard to make mistakes because you got to press the insert thing, and these keys have to be exactly bit for bit, exactly the way they are. There can't be any spaces. There can't be any sort of special characters or accidental thing. Like you can't open one of these keys up in Microsoft Word, because when you save it, Microsoft Word will put junk in it and it won't work anymore. So I would they're usually stored in vi tilde .ssh, which is a private folder, and I do id_.pub. That's my public key. And so you see, like, you can't really read any of the text, but here at the bottom you can read this, which says like this is the user account on the laptop, and then this is the name of my computer, Keith MacBook Air.local. So when that key was generated, it was generated to be used on this computer. Now, if you were a hacker, you could like change that and make it so it works on somebody else's computer, but ideally this is supposed to be locked to the computer that it's on. So once I open up this, what I do is I just copy the public key. I come over to GitHub. I'm going to go over to my settings. Oh, I'm already in settings. I'm going to add a new key, paste it, and I just say this is my MacBook Air key. Save the SSH key. It's going to ask me this password again. And that key is now in there, okay? I'm going to come back to the terminal and try to push. So quit out of this. And then I'm going to try to push. Whoops. Git push origin master. And it did it. All right, so my basic point is that you got to know about, at least carry away something with this under. If you don't understand what I'm talking about pretty good about public-private keys, you should go and search on the internet and like read an article. Maybe I'll post an article that's good to read inside of Canvas. But since it is the security of the internet, and you do encounter it in different places where people want you to give them your public key, like, so if I had an employee, I would have them generate a public key. I would take that public key, put it in my system, and then that would allow them to log in to whatever system I had and do it in a more secure way than a username and password. Because you really can't crack public keys. Like, it takes a lot of effort. Because just think about, like, you know, the public keys are 2,048 characters, and they can be more. They can be 4,096 or something, or 4,056, or even longer. And you figure you can guess somebody's password. You could brute force somebody's password that's 5 to 10 characters long. But you really can't brute force a password that's thousands of characters long. Does that make sense? Now, just a quick, I can put this on tape, but to answer your question real quick about the government is two things. One, the government does have the computing power to crack a key. There are bugs in the key system. And three, which is a totally, this would be like my imagination. I imagine this, so this is fantasy land. But do you guys ever hear of quantum computers? All right. Now, we're not getting into how quantum computers work, but the big thing about quantum computers is that they crack these, they don't maybe do it yet. Maybe somebody's got a secret quantum computer that does it, but they're real hot on making them so that they can crack these keys.
256 is already...
Right, but the quantum computer is going to be able to crack these keys in seconds, no matter how long they are.
Yeah, but if it gets bigger into, let's say, 1024 or 2056...
Yeah, well, this is so little side about this. This is one of the worries, and we'll go on. One of the worries is, like, this is the nightmare on the internet that people don't know about, is that at some point in the next X number of years, maybe 5 years, 10 years, nobody knows exactly when, and I estimate the government can already do it, because that's why I think they didn't need Apple to break into the phone. It takes a long time, though. It takes a lot of resources to do it. So it's not something you want to do every day, even if the government wanted to do it. Quantum computers are going to be able to do it real fast. They're scared of quantum computers for that. But the nightmare scenario, like if you see this headline, I don't know, like the world's coming to an end, maybe. That they're worried that somebody is going to come up with a way to crack these RSA keys. And if that person's able to crack these keys, they're going to be able to access every single computer, every single bank account, every single thing in existence on the internet. And they'll be able to go to Google and just send a command to Google like they owned Google. And the question's going to be, whoever does that, which somebody's going to do it, because it's like the eyes on, it's like for governments, like national, like state actors, and for criminals and just researchers, it's like the holy grail of security breaking, because it totally negates the entire computer security industry that we would have. And so they think that the processors and stuff is going to get cheap enough over the next maybe 5 years or so that this becomes possible for non-state actors, like non-governments that have unlimited, processing power. So it's likely to happen at some point, and someday, and maybe they're not going to tell anybody, but if you see anything on the news about like public-private key authentication has been broken because it'll be a news story on tech or maybe the first page of the New York Times or something, it's going to be a bad day. Because it's going to be a problem. Now, the reason why they are, just to back up, the reason why they're also hot on quantum computers is that quantum computers are offering the answer to that race. So like, imagine there's a race to break the RSA keys and to do it cheaply. There's also a race to build the quantum computers because the quantum computer can break the key, but it also can create security that is unbreakable, that can't ever be broken because it's not part of a human-designed system. It's actually quantum physics, and you can't break quantum physics. And so they want a quantum computer to be able to do the functionality of this RSA stuff so that so that you have ultimate security there. So like quantum computers are like maybe 10 years away, and then that's going to be like the future of keys. So, because it's sort of like funny, because like the day they have a quantum computer that can make keys and do everything is the day they got them to break it. So it's like, as soon as they figure that out, there'll be a mad rush to like deploy the technology. All right, so I just pushed this up, and I'm gonna go back to the repository. I hate the way, like, GitHub used to have a better front page. It just like showed my repositories, not all the news. All right, so here I'm gonna refresh this and see how it came out bold, and now I got a link to Google. Got it? So now what I'm gonna do is I'm gonna show you, we're gonna go through real quick like a couple different techniques with this markdown that you need. Like, so right now we have an external link. That would be like for your references, but let's make an internal link. Let's make a new page, make a link to that new page, and see how that works. Okay, what is the process for this? So what I would do is, first what I'm going to do is I'm going to go and say, I'll do this a couple different ways. So first you could do touch, and I would do, let's say, git.md. So the markdown files have to be named either .md or .markdown. .md, that is generally what they have to, is the best one to do. So touch is a Linux command that just makes an empty file. That's all it does. So vi, you can also do vi and open the file up or create a new file from scratch. But touch sometimes you might just want an empty file because you're going to make a few files at one time. So I would do vi git md, and then I'm going to put # git tutorial, and what I'm going to do next is I'm going to save this. Oops. I'm going to right quit. Then what I'm going to do is I'm going to do vi readme, and I'm going to make a link to that file so it shows, so I have the two files together. So I'll type insert, and then I'm going to say git tutorial, close the bracket, put a parentheses, then I'm going to type in / git.md, close the parentheses. And I'll show you one little trick here because it'll keep putting, a star will give me a bullet. Like if you want a bullet in a HTML, you got to type an unordered list and type a list item. Here you just type a star. It's like makes things a lot easier. Or if you want a numbered list, you just put numbers. It makes things like easier.
Are web servers ready to handle markdowns versus an HTML?
Some are.
Like which one would be?
I don't know, but you can make plugins for it. Like, sorry, I'll go on a little tangent real quick to answer your question. So it's not a new technology, but it's like used a lot. So for example, You ever hear of a content management system like
Yeah.
Drupal, WordPress, whatever? Well, they have what's called static site generators.
Oh, okay.
Okay, and if you have a site that's got a lot of traffic
Mhm.
to it, what happens is that it has a special kind of web server. That's the static site generator, and it watches the folders that all the Markdown files are in, and then automatically just processes the Markdown files and instantaneously updates the HTML. So it has like static HTML and Markdown. The Markdown is typed out, the server looks at it, and then it dumps it into a directory that is served by Apache or Nginx or whatever.
TeamSite, which was a content enabler.
Yeah, something like that. I heard about that.
So you put in flat files here with the elements, and those elements will get chucked out of the file. So the business would put in their text. Those texts will get pulled out.
Right, like a really nerdy thing to do. Like, hey, this is nerdy as hell. Go on Dropbox. Maybe Google does this too, but on Dropbox they make it so that you can put a public web folder on it.
Mhm.
And then there's instructions on how to do this, but basically you can make a blog hosted out of your Dropbox in Markdown. Because Markdown has ways of making templates and like regular sites and everything, and you can basically put a folder on your desktop computer that's a Dropbox folder, and that folder can be linked to the internet, and then you can dump Markdown files in there, and when they change, the site will be updated. So Git tutorial, and I'm going to right quit this, and then I would do, see, this wouldn't be a feature because I really didn't do anything yet. This is a task, like just setting this up, setting up the link and I would do a git add. All right, first of all I'm going to do is git status, just to see what we got. So we're going to have a readme file and a git.md. So I'm going to do a git add readme and git.md. Then I'm going to do a git commit -m fix or task added git tutorial page, and then just do git push and just push. See, once you get that public private key thing set up between your computer and that, it's like one extra step without having to type the password and stuff all in. It just sends it right up. So I'm going to refresh this, and if it works right, I should be able to click on this link, and then it'll take me to the Git tutorial page. We got this a little bit, and we're recording it so you can redo the greatest hits later. Go ahead.
One thing that I keep getting stuck at is when you do buy and get out of it. I know you do WQ, but
How do I get to that?
yes.
Shift :.
Gotcha. Thank you.
All right. So in Vi, just as like a real quick, like, hey, there's the things you can do with it. Like, so we've done Shift Q and all that. It has lots of features, like that, but you got to look at the tutorial to see what it is. That's why I said make a tutorial on Vi, because you really want you to get into it. It's got search. So like if you put a slash, a forward slash, and type what you're looking for, it'll do search. I think it has replace. And one of the things I really like about it is, like, a lot of times in programs you get errors and it'll tell you the line number, but then usually you end up scrolling up and down or something to find it. In Vi, you can just type the line number, like you do Shift :, type a line number, and it'll go right to it. And also Vi has undo, so we'll take a look at this. We're gonna I'm gonna show you a little bit different way to use Vi and a couple things while we do a couple other of these Markdown examples. So the next thing I want to do is, so we got, hey, we can make an external link to Google because it's like that's right on the tutorial, and we can make an internal link. The internal link, the trick with the internal link is you don't put HTTP, and you start the link and you start the file name with a forward slash. Okay, so just like looking at here, it's just the name you want to show up, and then slash the file name inside the parentheses. So anytime you want to use a picture or a link to another page, or you got to specify a file path inside so it knows where to get the file, you start it with a slash for anything that's inside your own.
So what constitutes a feature then? If this is not a feature, at least you just added a link.
I just added a page.
Right, or you added a bunch of content.
It would be like the feature would be the actual content. Like I did how to use Markdown. Like if I made a part of the section, like a section that was like, or on the Git page, I go and make the Git page and I put in Git remote, and this is what a Git remote is, and this is how you add and remove and edit and add, remove, list. Got it? So it's actual content. Like you want to, it's sort of like, I know it seems redundant and like people don't like doing things like in a procedure, but it's like just get used to being detailed with your Git commits and tracking each little thing you do. Now, one of the things that it seems like to be a pain in the butt, because you see me jumping in and out of I, this is going to be a mind blower. Watch this. So what I'm going to do is I'm just going to open up a new tab. I'm going to pwd just to make sure I'm in the right place. And then I'm going to do my Git commands inside here, but I'm not going to get out of Vi. I'll save Vi, like I'll save Vi, but I'm not going to keep writing and quitting. I'm just going to, now what I'm going to do is I'm going to add a picture. So the way I add a picture is I'm just going to go over to the Git tutorial. And we're going to add an external picture, and we're going to add a internal picture. So we'll do internal and external. So I'm going to insert this link. I'm going to write it. Then what I'm going to do is I'm going to come over to here, and I'm going to do a git status. And here we got an issue, and this is like planned, and we're going to know this. So the one trick is, and I didn't do this first because it's like throwing a little curveball at you.
You didn't close the other one, is that why?
Right. And if you got cut off, it would also have it. So you end up having a swap file. Okay, what is a swap file? It's like Git auto or Vi auto saves your work. Got it? So the swap file is where it auto saves. And sometimes when you open up Vi, it'll give you a message when it first starts up about, do you want to retrieve the swap file? Because maybe you got disconnected and you want to retrieve what was in the autosave, or do you want to delete the swap file and go directly to the file that was last saved? Now, we don't want in our Git repository to save our swap files. We don't want to send the swap file, and I don't want to see swap file as a problem all the time. Does anybody know what I should do to get rid of that problem?
Close and save the other file.
Now, there's an elegant solution to this. No. No. What file? I'll give you a hint. What file didn't I create this repository with? Remember when I made it? I didn't add this one thing that's like I usually added it. Like what?
No, the ignore list.
The Git ignore.
That's right. So you can put a .swap ignore.
So what I'm going to do here is I'm going to do a vi.get ignore, and then I'm going to do star.swap.
No, it would be .swap, right?
No.
Oh, you want the file name.
Right. It's everything that has a swap file extension.
But then the changes won't be saved if you just not include
No, they're not going to be tracked by Git. We never want to send those we never want to send the swap file to GitHub or track it.
Right, but what if you're trying to send it so then that swap will get ignored and it never, so the old changes will get pushed in?
Well, whatever changes you saved inside the text file is what you want, and that's going to be.
You never saved it, so it's still open, and then you're trying to push. So obviously, it's not going to see that change.
No. When I have the Vi open and I wrote,
okay.
So as soon as I open up Vi, it starts that swap file, and it doesn't matter if I press Shift:\W to write the changes, to save the changes, it still has the swap file.
But when you quit WQ, then the swap is done and the changes are accepted.
Right, but if I'm going to have two terminals open, and one I'm editing Vi, and I'm not jumping back and forth, because don't you think jumping back and forth between the terminal of Vi and doing the git commands is tedious to go open and close, open and close, open and close, open and close? Don't you think it'd be easier if I just have Vi open all the time, save my changes in Vi with the W or Shift:\W, right, and then as I'm going, I am just doing my commits. One window for commits, one window for the text editor. But if you have two windows open, you're going to catch the swap file.
But it will not make it. All your changes will be saved. But
Every time I do a W.
Yeah, it'll be in the swap though.
Right, it'll be in the swap.
It'll never make it to the original until you actually close it.
Until I actually write it. Until I do Shift:\W, the changes will not make it into that file.
Okay.
They'll always be in the swap file.
Gotcha. Okay, so that was the clarity I did. So if you, the moment you do W,
That saves the file.
and it also puts the original, the changes in the original.
Right.
file.
That's the only way the original file ever gets modified is by Shift:\W. All the changes that are done in the interim, that as you work, are being saved in the swap file. And if I closed the window down of Vi, like the Vi window, and rather than Shift:\Q or right quit and got out of it cleanly, when I tried to reopen that text file, it's going to ask me, hey, do you want to reload the swap file? It's going to say, there's a swap file here. Do you want to load the swap file because we want to get your changes before you actually wrote them? Or do you want to ignore the swap file and start off with what's really in the file? It's sort of like, you ever have a thing in Microsoft Word where it's like, do you want to recover this document or something like that? So it's basically the same thing. It's like, do you want to recover the document or do you want to go to the one that's been saved? So here, I just do WQ and get out of it. And now I'm going to do get status. And now I got a git ignore that's red. But here, what I'm going to do is I'm just going to do a git add dot get ignore. Now I'm going to do the commit. Git commit -m added or task added git ignore. So like this would be like a real task. Like this has nothing to do with the final product. This is just I had made a git ignore and I'm saving it. And in order to get the git ignore in GitHub, so that whenever anybody else would download this and they wouldn't have to take the Vi swap file out, then everybody would have a git ignore that went good with Vi in this project. And then I'm going to do git status. And I should just have the README file. And then I'm just going to say git add README and then git commit -m. And I'm going to say updated Markdown to add a picture. And I could just say make this a feature. And now I'm just going to do a git push and that's going to take everything up. And then I'm going to look at my repository. And there's my picture. Now let's do it with a picture that we have on our local, because a lot of times, like you might, a lot of you have Macs, and you can make nice screenshots. So you can do Command Shift 4, and then that will. I'm actually going to escape out of it, but so let's say I wanted to get a picture of this repository. So I do Command Shift 4, and then that allows me to select the screen and saves the file to the desktop. So what I got to do then is here's my screenshot, and just for convenience, I'm just gonna, in the desktop, I'm just gonna be repo, just rename it so that I don't want to type out that long file name. I just want to rename it something simple. And then I'll show you 2 ways to do this. One, I could just take the file and then dump it into the folder, okay? All right. And I can also copy it, or I can move it through the command line. So everybody can drag and drop. Let's do it. I'm going to do it through the command line just to show you. So let me clear this so it's, why are we not? All right, so the first thing I'm going to do is, before I move it, I'm going to do mkdir and put an images folder. And then what I'm going to do is do a cp, remember dot dot backs up, slash, and then I could have, I think, and if on the slash, I don't know what the file's called, as I'm typing it, I can hit the tab key and it'll let me peek into the directory. So like I can start typing the command and like I don't know what that file name is on my desktop or forget. Rather than looking on the desktop as I'm typing out the command line path, if I get to a slash, I can tab and I can hit the tab twice real fast and it'll peek inside the directory and it'll show the directory above me. So now I can see RE and I hit tab because tab auto-completes. And then what I want to do is I want to move it into the image directory, and the way I do that is I put period. Period means current directory. That's like shorthand for the current directory. /, and then I put it in images. And then just to show you, like, if I do ls period images and just keep hitting tab, that's when it peaks. This is way, like, just this little mini thing. But to me, when I learned how to do the tabbing and the up and down arrow for command history, that's basically whenever I said, I really don't want to use the windows to, like, clicking on the buttons and clicking through the UI. It takes too long. Like, if I have to work at a computer every day and use it as like a power user and deal with files and folders and file extensions and moving things from one place to another and renaming things and doing all sorts of things, it's mind-numbingly slow to always have to click buttons. And you just have to remember that the tab gives you peeking and autocomplete on the file names as long as it matches a file name. Like 1 tab autocompletes as best it can. 2 tabs peek to wherever you're looking. The up and down arrows do a history of commands, so you can back up and go forward in command history. Also, just show you real quick, because you have these tutorials to do, you might want to think about this. There's a command called history, which I didn't think I showed you. And, you know, like, you ever notice that, like, you find tutorials for Linux stuff, but you don't find it for Windows? Like, you might find some tutorials for Windows, but sometimes not. People don't want to record videos for it. But here with the history command, I can get a history of all the commands that I typed and then just copy and paste them out and then paste them into a text editor to put them in my tutorial. So, like, if you forget commands, like I'm forgetful, and I like that if I just type history, I can see all my commands, or I can, like, go fast forward, or go up and check them. You know, I just can repeat them through the... All right, so now once I had the picture, you always put the pictures in an image folder. Images, image, whatever you want to call it, images. Put it in a folder. mkdir, make an image folder. You put the folder to put the thing in. A little aside, my kind of thing is, I got a dirty room. My room's a mess at home. Really? It is. Seriously? I got mess. But in my computer stuff, I had to fight my messy nature, my lazy nature, to be precise and not screw around with it, and force myself to be as neat and clean as possible when I do computer stuff, because it is a big problem to have mess and messy file systems and losing files and just to do that. And I looked at it like, well, nobody pays me to clean my room, but people pay me a lot of money to do computer work, so I'm going to force myself, even though I'm messy by nature, I'm going to force myself to always be on point and clean and right on my computer file management and naming and everything. Like, just because I found that by being messy and not disciplined, it just took longer to do stuff and find things. It was a really important thing to just say, I'm not going to be sloppy. Anyway, so I can ls and I can see the files. And so I got my git.md and license everything. So I'm going to go vi into gitmd. I'm going to do it inside of there. I'll do this text. So what do? I'm just going to go and copy some code. I'll go over to the tutorial here. And copy it. Because I just need the basic format of the command. And I'm just going to delete the URL. Can anybody tell me what you think the first character I'm going to have to type for an internal file? /. So
you can put a dot too, right? /.
No, not in this. Not in it. It might take it. You could try, but I don't know. Like,
dot will be your current working, which is //
No, this is
dot and go
see.
forward up.
Okay, I can only think so much, but in the GitHub, they're doing things with the URLs, like, because this isn't, when this goes up, I don't think it's in your current directory. Like, I think that the period would confuse it. You could try it, it might work, but it might not. We could try it.
It's a relative path, so wherever this MD file is, so
if it see here, if it was a relative path, it wouldn't have a slash to begin with. The slash causes it to go to the root. It's making it be an absolute web path, basically. Like, if I didn't have the slash, it doesn't work.
So then how would you get to one level above, which is images?
You might have to do a dot. You might have to do a dot.
That's what I'm saying. / images.
But a period is different. A period is current directory, and that's gonna maybe not tell it to go to the root directory of the site. I don't know. We could try it out. It might work, might not work, but you don't need it. You just put the /. So here I would do. I think I called it what? Git dot. What did I call it? Git dot MD. Or it was PNG because it's a PNG file. Let me just look real quick because it's weird. I have a memory for certain things, and then my other memory sucks. Like, I remember concepts and stuff really fast, and names, what the heck I'm doing right now is like, I forget. So, and I'm just going to call it a GitHub repo. So right quit, and then do git status, just so we can see what that's going to be. And so we got .git has been modified and images. So what we got to do is git add git.md and then images. We're going to add everything in the folder. So you can do that. You don't have to type out the whole thing. Git status just to check that we got everything. Now it's like it picked up images, repo, PNG, modified. So now I'm just going to do a git commit -m feature adding images or adding local images. And then do git push origin master. And then let's just check it maybe I messed up. Let's see. So we got images, repo. So we got a problem here. Why is it messed up? Okay, let's take a look at this. Oh, I forgot to put the folder path. So write it, and then I have this open. It can become my command. So I'll just do git status. So git add git.md git commit -m fix image path for git repo. Git push origin master. And then let's try it again. And there we go. We got our image. All right, so we got one more little git trick. So let's do a task list. So this could be a change log or a task list. And it's pretty easy to do. So I'm gonna So I'll do two at one time because I want to save time, but because they're both useful. And we're going to do the first one we'll do is I'll do them one at a time. So there's two ways. Well, we'll do task list first. So let's do task list. Oops. Where did it go? I'll grab my to-do list off of here. So here you can do a task list, and that in the tutorial that is there, it has it, but I'll just quickly find it here. I'm going to come over and on my Git tutorial, what I'll do is quit out of here and vi on the README. So on the README, we might want to put at the bottom of it or at the top, depending on how you want to do it. But I'll just do it at the top. I'm going to paste this code in. And it's real simple. Because like you got a simple project. You don't need a fancy task manager. You don't need all kinds of stuff. You just, hey, get in your group. What are you going to do? Write down what you're going to do. Because you should break things down into small units. Because the smaller the unit, the easier it merges. And that's, you have to get 10 anyway. So you probably need 10 tasks per person. And that's what it is. Now I'm saying like it needs 10 tasks per person, but the stuff has to be complete and look good because you only get half your credit for just having commits. The other half is like, does this thing really look nice? And is it complete?
You didn't say that.
I did in the points. It's like 25% for how that it's well written, 25% for is it correct? or is it formatted nicely? So here what's kind of cool is that you can just put brackets and X's in the brackets to have checkboxes. So like whenever you fit, like you would edit it, you do something, then you come over to the README file, put a check mark by what you do, and then this comes out as a nice checklist inside of the repository. So I'm going to write this, and then I'm going to go back to here, and I'm just going to git add README git commit -m, and I'll say updated or task updated task list git push, and let's go take a look at it. And see, you'll get great, you get the checkboxes next to it. So that's a good way to keep track of who does what. Like you just, in the beginning, just put the brackets around undone tasks that you decide to do. And then as you get them done, put your name by them and just keep marking them off to get what has to be made. And then the last thing I'll show you for this is the code, because there's two ways to do code and it's not totally well explained. One way is, the other one isn't. So I'm not 100% sure all the languages that GitHub supports, but I think JavaScript, Python, Java, most of the common ones are supported. So what I do is, let's just look at this real quick. So I'm just going to copy and paste this into my README file. What it is you do 3 ticks, okay, 3 apostrophes, the name of the language, then whatever code you want to put in, and then you close down the tick. You put 3 ticks at the end, and then what's going to happen is that code's going to be syntax highlighted so it looks nice. So I'm going to go over to my terminal, go to the README file, and I'm just going to add this to the README. And then the other thing you can do is, if you don't have, like, so for instance, Linux commands don't really have syntax highlighting maybe. So if you do
I think they do with the black background.
some does. I'm just going to show you, like, hey, if you can't figure out what language to put in, then you can do 1, 2, 3, and on the 4th one, I can say command like history or git clone repo link. All right, so here I'm gonna save it, come over to the tab, and I'll just do git add readme git commit -m and say task or feature added code tag for Markdown. And get push origin All right, now let's take a look at what it looks like. Oops, I'm looking at a picture. Oops, I didn't put enough spaces. So let me fix that. It wants 4 spaces before you start typing. And I would just get get By the way, once we start doing coding, I'm going to get you a real editor. You're going to get excited because you're not going to. I'm making you type right now a lot for this without showing you a real editor, like that has Git integration and does all these things for you. Because if you ever have to take a test on this for a job, they ain't giving you an editor. They're going to make you do it on the command line. So you need to spend a little bit of time like making sure you command lined it yourself. But don't think that this is how you're going to actually work for most things. You're going to get a real editor.
Is that through NJT?
Yeah, we're going to get this. I'll show you what it after this is over. I'll show you what you're going to get. So
because doing this commit, can we not have a markdown locally and test it out, see how it looks?
No, there's markdown locally. There's markdown websites. There's all sorts of there's markdown editors. Like you can go get go look. Like I don't mind doing the markdown this way. So and I don't. But there's a lot of different markdown previews, markdown this and that. There's all kinds of things.
Commits are commits.
Well, the editor's gonna like. Let me finish this. So git push. And then it's hard to see a little bit. Maybe the contrast and projection, not too bad. But you see how the commands come out in the gray? Or if you have a language, it's syntax highlights. That's helpful. Because like what you're looking for is not like writing a book. Think about your mindset. Like you just want to know, is this what I need? Maybe have some conceptual understanding of it a little bit, of like what is it for? And then how do you do it? Like an example of why would I do it? Give me an example, show me the code. Put the code in highlights, use bullets, like less text, more formatting, so that the stuff looks good and it's easy to scan. And if imagine like I'm sort of self-serving this, and I have no plans to do this, but imagine I was going to have to teach high school kids how to code, and or the next time a class comes in here, wouldn't you like to have a book like this to help with all of the sort of questions that students might have, and have a manual of all the things that were needed? So think of it like that. I've had people do this assignment before and I've never used it before, but just think about it in that mindset, as this is something that is for you to keep track of what you learned, and you would want to look at it as and that's the way I'm going to grade it. Could I give this to somebody, and are they going to learn from it and be able to use it to help them? All right, so let me stop this. So online guys, we're done with this. So you should have an idea of how to complete your assignment.